Hi, I'm Alaina Spencer, and for my project, I researched black holes. Today, I'll be sharing what I learned about them. So this image is an artist's rendering of a black hole. Very few real photos have been taken of them, as not even light escapes their gravity. Black holes can form in a variety of ways, but the most common is stellar death. These bodies are called stellar mass black holes. Stars produce energy through a process called nuclear fusion. Our sun specifically carries out nuclear fusion when hydrogen atoms collide, eventually forming helium. Since mass is lost in this reaction, energy must be released. The diagram shows how the proton-proton chain works in our sun. When nuclear fusion in a star's core slows down, its death is triggered. The energy produced by fusion exerts an outward force on the star, which counteracts the body's gravity. Once this force weakens, the star cannot support its own mass. Larger stars will expel outer mass in a supernova before collapsing rapidly in on themselves. Once this process begins, a star may become a neutron star or a black hole. Those less than about 3 solar masses will be condensed into a small, stable neutron star. Neutron stars are the limit of compression. Matter in these bodies is packed atom to atom. If a star is larger than 3 solar masses, its mass cannot be contained in a neutron star. Nuclear forces cannot oppose its gravity, and the mass collapses indefinitely in on itself. This forms a singularity with effectively infinite density. This chart shows the paths a dying star may take based on its mass. Black hole formation is shown on the bottom branch. The name black hole comes from the fact that not even light can escape the body's gravity. Scientists classify black holes based on their mass, rotation, and charge. The objects can be found with a wide range of characteristics. The smallest type, primordial black holes, theoretically formed during the Big Bang. These have a mass near Earth's. Stellar mass black holes were described earlier and form from stellar death. They are between 4 and 100 stellar masses. Intermediate mass black holes are far less common, but are 100 to 10,000 solar masses. Finally, supermassive black holes are between 10,000 and 1 billion times the mass of our sun. They are found at the center of many galaxies and may form when smaller black holes merge. This artist rendering depicts our Milky Way galaxy. The arrow pointing to the center shows the location of a supermassive black hole, while the lower arrow shows our location. Black holes can also be categorized by charge and rotation. Of these, rotating and uncharged Kerr black holes are the most realistic scenario. Schwarzschild black holes are non-rotating and uncharged. Reissner-Nordstrom black holes do not rotate and have a charge, while Kerr-Newman black holes rotate and do have a charge. Technically, a black hole is defined as any body with an escape velocity exceeding the speed of light itself. Escape velocity is the speed an object must achieve to escape another body's gravity. It increases with gravitational pull. According to Newton's law of universal gravitation, black holes will exert a very high gravitational force. This is due to their large mass stored in a tiny radius. At a point known as the event horizon, a black hole's escape velocity equals the speed of light. An object has no reasonable chance of escape past this radius. A phenomenon known as spaghettification occurs as a mass is pulled into a black hole. Near the event horizon, gravitational acceleration increases so rapidly that the top and bottom of an object will experience different velocities. This stretches it into a thin shape, resembling a spaghetti noodle. If a person were sucked into a black hole, the same thing would happen to them. This image depicts the anatomy of a black hole. The event horizon and singularity can be seen in the center, and the glowing ring is known as an accretion disk. Since not even light travels fast enough to escape the event horizon, black holes cannot be directly viewed. Scientists must detect them with other methods. As material falls into the black hole through accretion, it accelerates rapidly and may emit X-rays or visible heat. Scientists can detect these features. Some supermassive black holes also eject supercharged particle jets. Additionally, a large gravitational disturbance with no clear cause may indicate the presence of a black hole. So this is an image of a real black hole taken by NASA. It was an important milestone in black hole research as it was the first real image captured. This page shows the references I used for my project. And here are the references I got the images from. I hope you learned something new from my project.